could be judged with respect to homogeneity of acquired data, which means the number of sequences acquired is homogeneous. There are no duplicates or incomplete measurements. The acquisition parameters are homogeneous, such as repetition time, echo time, number of measured scans, and so on. Then the data quality could be assessed with respect to validity of dataset space for the analysis, mostly three-dimensional space. Or it could be judged with respect to scientific questions, which mean homogeneity of subgroup of patients and so on. And today, I want to speak about the second case, about the validity of dataset in three-dimensional space. And for these purposes, I will show how to use two tools we developed at our laboratory, a tool Mask Explorer, which is suitable for searching for presence of artifacts, MRI artifacts, or processing failures, and a tool Movement Info, which is suitable to search problems in the data related to movement, head movement mostly. So some motivation. If we have missing data, then we can reach missing statistic value. As, for example, shown here at the image in the middle, if we use the statistic analysis as we have with the missing part of the left cube, then our final statistic mask or final statistic space will be incomplete, a little bit decreased, and we have to decide whether to discard this one specific measurement to get less measurements but better space for statistic analysis, or if we omit the space of the statistic space and want to have more measurements, as is shown on the example in the left. Reasons for presence of such inconsistencies are more. It could be, for example, failure in preprocessing, subject with shifted field of view during scanning, and so on. So now I have here an example. This is an output of independent component analysis made on data from patients with Parkinson's disease. These are axial slices, and you can see that there should be a default mode network, which is mostly present in most brains, but there is not present activation at the edge in the occipital areas. And now the question is whether this is some specific to the disease or whether there is a problem in the data. And obviously, there is a problem in the data. We can identify the failure in preprocessing with the usage of the tool Mask Explorer. If we load the masks, as is on the left three images, then we can see that in occipital area there is some missing data. So if we load the data from the missing subjects, as is shown on the right half of the image, then we see that there is something shifted and some data are even not inside of the brain. And if we fix this preprocessing failure, we can even get the data back in the valid space of in brain. So based on this exploration, we were able to rerun the analysis. There is the first kind of analysis on the left and the improved analysis on the right. And you see that in the occipital areas, now the activation is present even in the activation is present in the occipital areas, which is not the case in the left. Here is the same, the view on the same data with different triads with of views with axial, sagittal, and transversal view. And again, you see that one hub of the network is present, is nicely visible on the data where we made the improvement. But if we wouldn't check the data quality, the hub wouldn't be almost visible as shown on the left. So the solution on such problems is exploration based on masks of the subjects. The mask is a binary matrix, three-dimensional matrix, where one, here color-coded as white, is a valid space of particular subject, and 0 is invalid space. And with the tool Mask Explorer, we can load all masks of all subjects. In MRI and fMRI research, at the moment, it is typical if we have many masks. It could be tens or hundreds of masks, so it's impossible to check them all by hand. And we create a binary group mask where we see where the whole group has valid data and where not. And for this purpose, it's good to use this tool. Here on the left, you can see all masks of the data set. In this example, we loaded 100 masks, and at the specified position, there is a valid mask from 88 subjects. So there are 12 subjects where the data are invalid. And on the right triad, we can upload any image we want to explore, whether there is any problem and so. With our tool, there are many features of this tool. If you click on specific position of your interest, you can add a coordinate to the list of coordinates, and then you will see all masks or particular subjects which are not suitable to data analysis with respect to this selected coordinate. So you are then quickly able to identify the individuals, and then you can decide whether there is a failure in data processing or data acquisition, and whether to discard such subjects from analysis or whether to fix something. There is also a possibility to automatically find outliers based on based on this mask of valid data. And then you will get advices which subjects should be explored more carefully. It's also possible to get a report of suitable masks suitable for such exploration. And if we make some analysis with regions of interest, for example, with respect to any atlas, then we can see particular brain areas and their coverages by particular subject. So we can decide whether we have sufficiently valid data for analysis in these areas. Another issue, another big issue related to data quality in fMRI data is head movement. Little bit similarly to photographs, if a subject is moving in MR scanner, you get data which are corrupted, which are blurred and distorted. On the right-hand side, you can see a brain scan when a subject was moving, and you see that at some slices doesn't look like brain at all. So there is also a problem that that a movement can cause signal changes which are similar to useful POLT signal, which is abbreviation of blood oxygenation level dependent signal. This is a signal of interest in fMRI data. And if this movement is correlated to time courses, this could be a serious problem. So prevention to this is to fixate well the head during the scanning, and to instruct the subjects carefully. At our laboratory, we have developed a tool which is suitable for exploration of time courses of movement, which are originating in preprocessing. These are parameters of rigid registration to of fMRI data to the reference image, which could be, for example, the first image. And then we can see translations and rotations in all three axes. There are a few metrics which quantify this movement, and we involved the metric frame-wise displacement. This is a graphic user interface of the tool. This tool is suitable for exploration of movement in big studies. So again, here are loaded parameters of movement from 100 subjects. And yeah, the tool, as well as the Mask Explorer tool, is freely available at NITRC websites. So now to have a closer look at this tool, once you load the data, you can set up specific thresholds to identify the data where could be a specific problem. For example, you can identify the threshold of frame-wise displacement. Here it is set to 1.5 millimeters, so you can see every scan where the frame-wise displacement is exceeding this metric, and you can let you list all the measurements where the threshold here is any of scan is exceeded. Yeah, so you can see that 6 out of 100 subjects have present such scans. So, and then it's advisable to somehow correct the movement in these subjects, in these scans. So you can discard these scans and interpolate them, for example, or discard them, or if there are too many, then you can discard the whole measurement. You can export some report of the suitable data to text files or Excel files, and you can also export the excluded scans based on the threshold setting, which could be later used for any analysis such as in analysis with general linear model of for example, task fMRI. Now I have here a combined example. For example, if you have a group mask which looks like this, you can be sure that there is something wrong, because in the middle of the head you see some space of invalid data. So this happened in a data set where we had 128 subjects, and we see that in one subject there was a huge missing field in the middle of the head. And then we, with the tool, our Mask Explorer, we identified this subject because we clicked on the missing position. We see that only one subject here has its missing position, and we have quickly identified this missing subject, and we had looked on his movement data with our tool movement info, and we can see that there was a part of the data where this the subject was movement really widely or more pronounced. And you can see that the data at the point of movement looked very abnormal. So if we look on the raw data, then few scans before it looked like this. Then the affected scan look very unusual. And in the following scan, the subsequent scan looks relatively normal, but there are some effects still present in the data, which maybe are not visible by eye. And this is the last scan. So again, looks quite normal. This is again on processed data. So we had to thread this data, and with respect to the analysis, the best solution would be to discard this scan and following scans. So to sum up, I have presented two tools, the tool Mask Explorer and Movement Info, which are related to exploration and validation of the three-dimensional space for the fMRI data analysis. One subject can significantly affect the analyzed volume, and even the pre-processing is not able to save all the effects related to the artifacts. So we should check the data carefully. So I thank you for your attention, and if you have any questions, feel free to ask.